All right. Okay, now let's continue the triangle congruent. Today's topic is overlapping triangle. This triangle overlapping, right? So we're gonna prove this one. The first, this is given. Okay, this line is up here, right? Okay, BE equals CF this side, and the AB, these two sides are congruent. Angle B, angle F is congruent. So from the given, you have to think which method will be available, right? For overlapping, okay, sometimes we can separate the figures. It can be easier, okay, to look at it, but you don't have to always do this one, okay? You don't have to always separate the triangles. But this time it's okay, right? Okay. So I'm not gonna separate this one because we're gonna find out these two lengths must be equal, right? The method is what? This is side, this is the angle for the given, this is another side. To prove triangles, the method will be side, angle, side. That's right. Yeah, it's gonna be side, angle, side. Now prove this one. The first, the given over here. And where is it? BE congruent CF. That's the given. AB congruent to DF, second given. Angle B congruent angle F, that's the third given. But this angle is already finished. This side is finished already, but still this is not finished yet because this is only given, this two side. So you have to find, okay, BC congruent EF, right? These two sides congruent, we have to show that. But BE already over here, from here CF. From here we're gonna extend it to EC, right? So you're gonna add EC to the both sides. EC congruent EC. That is reflexive. Now what I gotta do? These two side, congruent side, each must be addition, right? Okay, use this one. BE plus EC equal quantity, the sum also congruent, okay? And the CF and the plus EC. This will be set additions. Okay, right? That's the additions. The next one, but how can you simplify this one? B equal EC, B equal EC. Maybe you can use the OR. This is what left hand side, the BC congruent EF. You can use this one too, but I'm gonna use the general way, okay? Alright, general way is what is it? BC first, okay? So BC, this one equals to how much? Partition postulate, BE plus EC, right? BE plus EC, and also EF in the same column. EF congruent to how much? CF plus EC, right? That we said partition postulate. But this one equals to what? BC, right? This one over here goes to EF. So you can use substitution, okay? Instead of this one, you're gonna use BC now. BC now to the left, to the right, replace with EF, okay? That is substitution. Just a substitution is okay, or congruence. Now you got the 1s. Now this is done, right? So side, angle, side, side, angle, side. Now we can say now triangle ABC congruent triangle DEF. We all got the reason it was side, angle, side. Okay? So you guys can figure out this one more times before we're going to next. If you guys have any questions over here, you let me know, okay? This is recording. These steps just memorize from here to here, okay? Using partition postulate, you can replace with find the BC congruent EF, okay? Okay, screw up here. This is nothing. Okay, make small. That is better. This is page 25, okay? Any questions on here? Okay, now we move to the next questions, okay? Overlapping triangles. This is another overlapping. It's not overlapping, but kind of one, yeah. Disconnect, okay. Actually, this is not overlapping, okay. So which method will be available on these questions? So you have to check it out, okay? This is wrong over here, bar is up here, okay? QT SU, they are equal. But from here we can say these two sides we need is congruent because we need this side, right? Okay, yeah, that anyway, that is a side. Not finished yet. RQ, this side, and BU, this side, they are congruent. Oh, this one is fixed already. It's done. You got the one side. And RS, this side, and the BT, this side. This is another fixed one, all side. So this is side. This is going to be with what? Side. Okay? So write down over here. QR, I'm going to write down this one. RQ equal B first. RQ congruent BU already, that's done. The second one is RS BT over here, okay? RS BT, it's done. That's the given. Third one, QT SU, okay? But this is given, but this is not this side only, right? You gotta see that these two sides congruent, not entire here to here, right? So we need to take off the length of TS, right, from each side. So ST, congruent ST, right? This side belongs to over here, the other side, okay? It's the same length anyway. This is reflexive. The next one, number 5, subtraction, right? RQT, okay, QT minus ST, that must be equal to what? SU from here, SU minus ST, right? That must be equal, right? Okay, equal quantity Okay, when subtract from equal quantity, the result is still equal, right? Okay, this is SU. This is a subtraction. We have another partition law, partition partial rate. What is the partition partial rate? I'm gonna delete over here, right? Something. Partition partial rate looks like this one. First one, QT. This whole is equal to the what? Sum of each part, right? QS plus ST. That is a partition partial rate. Another one is what? You can use either of this one. QS equals what? QT minus ST, right? It's okay. This is also partition partial rate. Because what? QS, right? This one is what? QT whole minus each part, right? Whole minus each part still it's another part. That is also partition partial rate, okay? You can use either of this one. When you have a subtraction, better use this one, right? This is the partition partial rate. Excuse me. This both is called what? Partition. That because they are equivalent, right? 5 equals 2 plus 3, or 2 equals 5 minus 3. It is okay? They are equivalent, okay? So we have subtraction, and I'm going to use partition this one, okay? QS equals how much? QS congruent QT minus ST. This one first, right? That's empty. The next one is TU congruent SU over here, right? SU minus ST. This one. SU minus ST. This is also partition partial rate. Just partition is okay. Now QT minus ST is equals to QS, all right? Replace with QS to the 5, okay? That is, we set substitution. So now we got what? QS congruent. This one is actually TU, right? Replace with TU. TU. This is number 7. This is, we said, what? Substitutions of congruence, because they are congruent, okay? Just the substitution is enough, okay? Or if you like a little more detail, congruence. Now we got the QS equal TU is what? This side congruent, okay? But now we got the all side. Now we make conclusion, okay? Triangle QRS congruent triangle TUB, okay? That is what? Side, okay? Okay, just figure out one more times, okay? The step, each step, okay? Just try to follow the step. When you have a subtraction, okay, so using substitution, we need a partition, okay? Remember, this is a partition partial rate, okay? Either of this one is okay too. All right, move on the next, number 3. Okay, can I move on next, number 3? Okay. Yeah, this is overlap anyway. It's kind of overlap, the line overlap over here, right? Okay. So BCA, FED, take a look. We're gonna find the wedge method. BCA, FED, we have the 1 angles. This fixed one, done already. And the AE congruent to CD, right? AE this side congruent to CD or this side, but this is not complete, okay? The next one, angle A, angle D, angle A, angle D congruent. Yeah, this is angle side, angle congruent. Now this is going to what? Maybe this is reflexive, right? This side on triangle, this side on the other triangle, it's gonna be same length. So it's gonna be S again, right? So this is what the angle side angle, okay? This one should be angle side angle. That method will be angle side angles. Now write down angle BCA congruent angle FED. That's the given. A congruent CD also given. Angle A congruent angle D also given. So from number 2 we're gonna find something, right? A is only this side. So this EC to the other triangle, EC of the other triangle, there must be same length. So you're gonna write down EC congruent EC. These two lengths, okay, of the other triangles are equals reflexive property or reflexive is okay too. The next one you can add over here, right? AE and the 4, right? AE plus EC, AE plus EC congruent CD plus EC, right? That is by additions. Now using replace with this one is by AC or ED, we need partition postulate. Okay? AC equals how much? AC equals this side. This is AC. AE and plus EC. This side is what is there? ED, right? ED equals to CD and plus EC. And that is partition postulate. After that, replace with the AC, right? So number 5. AE plus EC is what is the AC, okay? Replace, that is a substitution. AC congruent, now ED, okay? Substitution. Here and here, here and here, okay? Now we got everything, okay? Angle all the way side, this side, they are congruent. Okay, now we can say triangle ABC congruent triangle DFE. Okay, the reason is angle side angle congruent. Okay, or some teachers like this one, angle side angle, the other triangle. Okay. Can you guys figure out the number 3? Alright, the next one, okay, we work together. This one, actually, we need the separations. Okay, a little hard to figure out. That's why we better to avoid this is a figure a little bit messy, right? SX this is XX and SY and XR YT, they are congruent. Using this, we're gonna prove, right, RSY. Okay, where is RSY? R here, S here, Y. Oops. In this case, I think better separate the figure, right? Here, S, here, here. This is R, this is S, this is Y, okay? The other side is triangle TSX, so this triangle. Take them out. This is S, this is X, this is T. Looks better, right? Okay. The first one, to prove these two triangles are congruent, we already got the one angle over here. This angle S is what? Same angle, reflexive. One angle already. They are done. Another SY equals SX, right? SY equals to SX. It's just said already. This is done. We already got one side and one angle. We need one more. Where is it? Where is it? XR equals ST. This equals, this is equals, this is equals. Okay, sum of these two must be equal to, right? So this one is not finished yet. It's gonna be side. Okay, so that method is what? Side angle side. But you have to prove that, okay? SR congruent ST, okay? SX congruent SY. XR congruent YT. SX plus XR, right? SX plus XR, isn't it? This one, right? This one. SX, no. SX, not XS. SX plus XR. This one plus this one equals, what is that? SY plus YT, right? You need the second one. SY times YT. This equals, sum of this one must be equal, right? So you can add this one. This is a partition postulate again, alright? Partition postulate. SR is how much? SR is actually congruent to what that? SX plus XR, right? This side, the right hand side, this one is ST is actually congruent to what is that? SY plus YT, right? This is T. There is the capital T, I'm sorry. Not little t, capital T. In 1, 2, given 3 is what is that? Additions, okay? Number 4 is what? Partition, right? Partition postulate. Partition postulate, the meaning is what is the whole is equal to the sum of each part. That is the partition postulate. Okay? This is the whole sum of each part, one part, two part. Now using this partition postulate, replace, okay, 3 in with these two lengths. The first SX plus XR is equal to SR, right? So SR congruent. Second one is actually equal to ST, right? They're equal, congruent. This was substitutions of congruence. Okay. Now we got everything. Now this is done. This is done S equals S by using the addition. Okay, that is a side angle side. And now you can say triangle RSY congruent triangle TSX. Side angle side. Excellent proof. Okay. Okay, I'll give it some minutes, okay? You guys figure out this one. Are you guys okay with this? Just try to memorize if you're still confused. Okay, the memorize gives you some idea. Okay. All right, we're going to number 5, next questions. Over here, number 5. So Premier, okay, I'm suggest, right? Which method will be available on this probe? If you guys have any idea, okay, you can chat me, okay? Which method? From the given, always method is from the given, okay? You have to decide, okay? Not anything else. Okay, which method will be available? Check it out and chat to me, okay? Okay, they are all over here. The line should be up here, okay? This row. Which method? Anybody can give me an idea? The method is side, side, side. Side, angle, side. Angle, side, angle, and angle, angle, side. The last one is hypotenuse length. This is only what? On right triangle. Anybody? Okay, this is the side already. We got the right picture one. Okay, another side over here, but this is from here to here, not from here to here, right? So you can use using subtraction. We can find these two sides congruent. Okay, also this is okay. Another side, and this is right angles. What is the side to side angle? Did you see over here side angle? Not working, okay? If you got this one, there's no other way, but this time side, angle side, when you have right triangle, that is the right triangle, but this is okay. This also side angle, but it right triangle is working. But instead of using side angle, we use the hypotenuse length, okay? So you gotta go this way. Are you okay with this? Okay, I'm gonna write down over here PQ DE congruent, and the PB and the AE congruent, and the QA perpendicular PE. Another one is the DB. I'm going to use the same column, okay, because you're going to use the same region. DB perpendicular PE. They are all given. This already fixed one, PQ and D. Okay, now using this PB and AE, we're gonna check right. PA equals BE. Okay, so this side, AB is what? From this side, AB the other side, same length. So we're gonna use what? AB congruent to AB. Okay. Reflexive property. The next one is subtraction, right? PB minus PA, right? So PB minus AB, this is congruent AE minus AB. It's okay. That is a subtraction. So what is this PB minus AB? PB minus AB equals what is that? PA. It's okay. So you can express PA. Partition part. PA is what is that? PB minus AP, right? This one. PB minus AB. Or AE minus AB is how much? AE minus AB is BE, right? You write down the BE equals what is that? AE minus AB. That is what? That's number 5. Partition pass rate. Now replace with the PA, okay, from number 5. So PB minus AB is a PA, okay, by PA congruent BE, okay. Now this side PA congruent to BE, that's another side, that's the fixed one. Substitution. Or you can use a sub, it's okay. That means what? Substitutions. Just simple, okay? Of congruence. Or just what? Sub is okay too. Now check it out. You got the side angle. But side to side angle not available here. No, we can't do this one, but we can do that because this is a right triangle, okay? So you can say that you have to say these two triangles are right triangle, okay? Angle PAQ, because they are perpendicular from here. Angle PAQ and angle PBE, right? PBE are right angles. The reason is what is that? Perpendicular line. I'm going to do some symbol, it's okay? There is a perpendicular lines form right angles. Now we can say triangle PQ, APQ, triangle APQ, because we're gonna go HL, right? APQ and triangle BED are right triangles. I'm gonna write. The reason is what? Right triangle as a right angle. That's why triangle is right triangles. Now we got the right triangle, and we got the hypotenuse over here instead of S. This is hypotenuse, leg. Okay. Now everything is okay. This is a right triangle from here. Okay. PQ is what? There is hypotenuse. And PA is over here, there is a leg, right? On right triangle, you got 3 over here, right? It is a right triangle, you got the hypotenuse congruent and the congruent leg. Now you can say the triangle PAQ there, okay? I'm going to show that. Okay. Over here, right? Borrow this order, okay? Triangle PAQ congruent triangle EBD. This number 9, this number 10. Yeah, congruent. The region is what? Hypotenuse, leg, or H by B, leg. Okay? Okay, that's the answer, okay? Just to figure out one more times. Already remember there are 5 different methods, okay? I'm gonna move to the next one. You don't need this one. Another overlapping. This is a little hard, but you can do that. After this, we have to write break of time, okay? Okay, we can, after this, we might have a break time. SPR, this is straight line, okay? I'm gonna write down SPR and SQT, straight line. PR congruent, straight line, and they are congruent, okay? Okay, they don't have to write SP, right? This is a line is what the straight line. Okay, I'm gonna, instead of this one, better use this one. RS congruent ST. It's okay, right? But this is better, I think. Alright, the next one, PR congruent, this side equals. And the PR, this side, and the QT congruent. Okay, you're gonna pull by triangle SRO. Where is SRO? This one, right? Oh, confused. You're gonna separate again. This is S, this is Q, this is R. The other over here, take them out. This is P, this is S, this is T. It's same as before, right? A little different proof, okay? But S is a common angle, okay? You got the one angle, reflexive, and where is it? SR congruent ST already, right? Over here, ST, right? SR, and this is the one side, that's the fixed one already. We need one more. Where is it? Where is one more? These two sides congruent, this side congruent. When you subtract, these two sides congruent, right? These two sides will be congruent. We got another S. Not finished yet. We're gonna prove this one, okay? So what is that? Side, angle, side, okay? Side, angle, side. We have to go this way. Side, angle, side. So write down PR congruent QT. This is already fixed one. One side, okay. PR is over here. Okay, so I'm going to subtract over here. I'm going to use this one, RS. RS minus PR. ST minus QT, right? Because these two sides is congruent. Is okay? And the RS, ST is congruent. Alright? Congruent quantity is subtracted of congruent numbers. It's going to be congruent. Okay? This we said subtraction. Now use the partition rate. Okay. RS minus PR is what? SP, right? This one. So I'm going to write SP congruent RS minus PR. And also ST minus GT. Where is ST minus QT equals what? SQ, this one, right? So that's going to SQ. SQ congruent, what is the ST minus QT? That is a partition rate, okay? replace this one with the SP, this one, okay? So SP now congruent SQ, SP now congruent SQ, right? That finished. S. So side angle side, everything we got. Okay. So number 5 is what? Substitution, right? Of congruence. Now you can say triangle SRQ congruent triangle STP. But this side is what? Side angle side. Okay? That is overlapping. But this time we better separating the figures. It's okay? Yeah. Not always, okay? Okay, we have some break. Everybody come back here. (7:55 p.m.) Okay. We resume our class and 7:55. Okay. So take a break. Okay. I'll see you in 10 minutes. Okay. Yeah, we have another overlap triangles. Okay, very similar to that, right? The beginning. Okay. Now check out. Always we need to check out the method. Okay, so which way we have to go. Okay, without this, confused, right? Okay. Check out which method we have to go. AE and FB. That means what? Using this one reflexive, you can say these two lengths are congruent. You got one side. And if we have to prove this, we are not done, right? The next one, DA congruent CB. This is already done. This done circle. So we have two sides. Another one angle, we need one more. Angle A, angle B, right angle. This is a right angle already. Yeah, this is angle. This is really there. We don't have to go a hypotenuse level. Very bad. What is that? Side, angle side. This one we have to go side, angle side now, not HR, okay? Side, angle side. Write down will be angle, not angle. Segment AE congruent FB, right? These two sides are equals. The second one is DA congruent CB. That's done. This is already done. From number 1, it's not complete. So we're gonna complete, okay, number 1, AF equal EF, okay? So you're gonna add over here EF and EF to the other side. That must be congruent. So this is a given. Second also given. Third one is reflexive. Reflexive property. Okay. And third, now we're gonna add this one, right? AE and plus EF. All right, from number 1, 2, 3, right? AE plus EF, this AE plus EF congruent FB plus EF, same length, reflexive. Okay, that is additions. Now using partition postulate, replace with what? AFEB, right? What is the AF? AF congruent to what? Is actually equals to AE plus EF. And also EB or BE, I'm going to BE congruent to what? FB plus EF. That is a partition postulate. Partition postulate. Now we replace, okay? AE and the EF, replace this with the 5. That is AF, segment AF, congruent, segment FB plus EF equals to BE, right? So we can say AF equals BE now. That's the side of that triangle, okay? This is we set substitutions of congruence. That's it. Now we got everything. Side, angle, side. Oh, not yet. The perpendicular, right? They said angle and angle B are right angles. Okay, you better write up there, okay? This is 3. This is a 4. This is 5. This is a 6. Okay? 3, 4, 5, and 6. I forgot to write over here, right? The given. I'm going to write down given over here. It's okay too. 7 is also given. Angle A and angle B are right angle. They said right angles already. Not perpendicular, right? Just they said right angles. This is another given. After that, you can say angle A congruent because we gotta go side angle side. We have to say they are congruent. All right angles. You already know that, right? Well, you can use all right angles are congruent. You can use this symbol. Okay, all right angles are congruent. Now you got everything, right? Side angle side. Now you can say triangle ADF congruent, triangle CBE. Now we got everything to say the triangles are congruent. The method is side, angle, side. Okay? That's all. That's a perfect solution, okay? If you got this one, nobody object. Okay? Alright, that is number 2. Just figure out one more times how we proved. Okay? Alright, move on to the next one now. Okay, find out which method. Okay, just give to me. Okay, so which method will be available on this question number 3. Okay, from the given, find out. Okay, I'll give you in a minute. Okay, go ahead. From angle 1 and angle 2, we can find this supplementary angle. They are congruent. We got the one angle, but we are not done. We have to finish this one. We got the one angle. DB perpendicular AC means this is also right angle, right? Perpendicular, another angle over here. This is done. We can finish. Okay, it is not done yet. We have to say they are congruent. Okay. We need one more. Angle side, DB, this side S, the other side triangle S. That angle side is okay. We gotta go this angle side, not hypotenuse leg. Okay, angle side. So over here, angle 1, Usually this symbol, okay? Angle 1, congruent, angle 2. That's a given. I'm gonna give them first. DB, they need this, okay, the bottom of that logo. DB, congruent, AC, okay? That's given. I'm gonna write down. Given. Okay, you wanna do reflexive first or angle, right angle first? Okay, this angle first because the given is right. Angle 1, angle 2 is congruent, okay? So the other side angle is this way, angle DAB, right? Angle DAB is supplementary to angle 1, okay? Or angle DCB, angle this we did already, okay? Angle DCB is supplementary to angle 2. Because these two angles on this straight angle we said linear pair, okay? Angles that form a linear pair. Memorize, okay? These angles are supplementary. Okay? Don't skip any words. Okay? Just memorize all these reasons. Angles that form a linear pair are supplementary. Okay? Angle 1, angle 2 congruent. These two angles congruent. So it's supplement also congruent, okay? So angle DAB now congruent, angle DCB, okay? Don't forget, just memorize supplement. Do not use a supplementary angle, okay? Just a supplement of congruent angles. I'm going to use the word. Supplementary congruent angles are congruent. Or you can use now, you can use this symbol, okay? Now you got the one angles finish. Angles is done. Another angle is what? Right angle, okay? Right angles, because what? They are perpendicular, okay? So this angle is right angle. So I forgot perpendicular, right? No, DB perpendicular AC. No, this is not congruent. DB we write down, okay? DB perpendicular AC. From here, you can say angle DBA, this angle, and angle DBC are right angles, okay? I'm going to do right angles, okay? Right angles. The reason is what? Perpendicular line. You can use this one, perpendicular lines form right angles. Well, you can use right angle. This symbol is okay too if your teachers use this one, okay? So from now on, these two right angles are congruent. The reason is all right angles are congruent. Okay, all right angles are congruent. Now we got the one angle already. Second angle done. We need one more angle. Yeah, the last one is what? What is side? Okay, this side angle side. Okay, so write down over here DB congruent, another DB. They are reflexive. The next one. Now we got everything, right? So triangle ABD now congruent triangle CBD. ABD, CBD, they are congruent. The reason is what? Angle, angle side. We all got that, okay? That's it. Just figure out one more time this one. You guys okay with this? All right. Move on next questions. This is overlap. ABCD is what? Straight angles. Line segment is the line. AE equals BA. BF. Yeah, we got one side already. You're gonna prove these two triangles congruent, right? So ABF, ABF. This is supplementary to angle A. Supplementary means what? Sum of these two is 180 degree, right? And we gotta prove what? Triangle AEC and triangle BFD, okay? Remember, these two angles are supplementary. It's okay? Alright, I'm gonna use the angle, I'm gonna use this angle 1, angle 2 now to make it simple, okay? Now the region over here, ABCD straight line, that's why we can say this angle is a supplementary, right? Because linear pair, right? On line, okay? Second one is AE congruent BF. We got one side already. And AB congruent CD, right? AB congruent CD means what? This is reflexive. Add both the common segment. This one must be equal. We got another S, but we are not done, right? So anyway, AB congruent CD, but we are not done over here. This is given. This is also given. Third also given. Number 4, write down over here. Angle ABF is the supplement of angle measured. You can judge supplementary to angle A. You can write down this one, okay? Another, this is given. Now let's find, this is already done. AE, BF, we had one side there. Now I'm gonna find, okay, this side, bottom is also same side, okay? AB plus BC, right? This is what's common length, isn't it? So you're gonna down BC congruent to BC. That is the side. Anyway, this is what? Side, angle side, we know that, right? Side, angle, side. Okay? That goes what? Side, angle, side. So from here, you can see AB plus BC from these two, right? AB plus BC, segment BC, congruent, CD plus BC, okay? Reflexive, that is why this is, I'm sorry, forgot this one, reflexive property. And this one is additions. But this one, we're gonna replace this one AC, right? Because AC equals what is that? AB plus BC, isn't it? And also BD equals what is that? CD plus BC. It's okay. BD equals BC plus CD, CD plus BC. That is what partition part rate. Now, substitution. AB plus BC is what AC. AB plus BC is what BD. They are congruent. That is a substitution. I'm going to use a substitution, okay? So, or you can use a sub or substitution of a congruence. Now, this one side already. Now, we're going to say these two angles are congruent, okay? Angle AB F and angle A. Oh, I'm going to this is angle A. They use it instead of 1. I'm going to angle A. Okay. This one I'm going to do F B angle 2. Okay, F B D. That's fine. And also what is that? F B D. Can you see that? F B D, right? FBD, angle FBD is what? Supplementary of angle ABF over here, right? Angle ABF. Okay. I'm going to use this one, okay, the other way, okay? Angle A is supplementary to angle ABF. It's the same thing, okay? Angle ABF is supplementary angle A, or angle A is supplementary angle B, okay? That is, I think, this is better, I think. Angle A is supplementary to angle ABF. That's the given. You can use this one too, okay? Alright. This is what? This already given, but this one you have to give, right? The angles. This one a little hard. That form a linear pair are supplementary. Okay. After that, now angle A was supplementary of angle ABF. It's okay. So you can write down the angle A is congruent angle FBD over here, right? Angle A congruent angle FBD. The reason is what? Supplement of congruent angles are congruent. Now we got this angle already, okay? This angle is done. Okay, so side, we got the angle, we got all side, okay, using partition, right? So we can say these two triangles are congruent. Triangle AEC, now congruent triangle BFD. It's enough to say this one, okay? The region is about side, angle, side, okay? That's a perfect solution, okay? Just to figure out one more times. This is overlap triangle proof, okay? If that looks meshy, okay, it looks meshy, you can separate, okay? Okay, move on the next one more time. After this, we'll finish today, okay? Yeah, because that's enough, I think. Next time, so we're going into some other topics or double triangle congruent. That is the hardest one. Maybe you can try double congruent, okay? That is AFEC. That's a straight angle, straight line over here. That's what we can say these two angles are supplementary, okay? Second one is AF congruent EC. AF congruent EC. Okay, that is the part of right, the length. We need to find the what? AE congruent FC, right? That is a side anyway. We got the one side. The next one, angle 1 congruent to angle 2. This angle 1 congruent angle 2 is what each supplementary angle are equal, right? We got the one another angle, but we are not done. We got the one angle already, okay? And also angle 3 congruent to angle 4. Angle 3, angle 4, that is all done, right? This is what you don't have to prove this, it's already angles. So the region is over here right there. Angle, side, angle, okay? You gotta go angle, side, angle way. Now you got the one angle already, angle. Now from number 3, we have to find, okay, inside number, okay, this number, this angle equal this one, okay? So angle DFC is a supplement supplementary to angle 1, okay? And also angle BEF, this angle, right? Angle BEF is a supplementary to angle 2. 1, 2, 3, 4, they are all given. That's number 5. Number 5 is what is that? Angles linear pair, right? Angles that form, don't forget this one, okay? That form a linear pair. These angles are supplementary, okay? From here we can say these two angles, because they are congruent, these angles are congruent, okay? Triangle DFC congruent triangle BEF. So these two angles now congruent, we are done, okay? The region is what? Supplement of congruent angles are congruent. You can say it this way, okay? Now the next one, we gotta say that this side, the other side is equal, right? So FE congruent FE, right? That is reflexive. That is a common line segment, reflexive. The next one, you can add this one AF and the reflexive over here, right? AF plus FE. That is congruent EC plus FE. That is addition. Now this one replaced with what? AE, right? Because AE equals AE, right? From here to here. AF plus FE, right? AF plus FE. The other one, okay, that's complicated. The other one, FC, right? The other side. This FC is what? These two sides. FC equals to, in the same color always, okay? This one, FC is what? EC plus FE. That is over here partition, right? Well, we're gonna replace this one. AF plus FE is AE. And second one, EC plus FE from here replace with the FC, okay? substitution. So we got the side already. Alright? This side, they are equals. We got the side. We got the angle. Okay? Angle 3, angle 4 already, okay? And also we have another angle over here, supreme angle already, and the side we got already, okay? So we got everything. So finally we can say the triangle ABE congruent triangle CDF. The reason is side angle side. We're done, okay? There are a little more questions there, but I think that's okay. I mean, next time we're gonna co-write CPCTC using CPCTC, and we have another one, two congruent triangle. This two congruent triangle, right? Let me see. Yeah, double congruence. Okay, this is the hardest one. Congruent triangle. Okay. Because okay, this is a little hard. We can do next time this one, okay? So actually in this summer we finished okay around 70% of geometry. Okay, because we couldn't do some of like circle, okay, circle proof and rectangle proof. Okay, so when your school year you're gonna learn in your school, okay? Alright. Because summertime is not enough. My plan try to finish around the way 85% and 90%. Okay, but I couldn't make it. Okay, all right. So next time we're gonna finish completely about the triangle congruence anyway. Okay, the last one is what CPCTC and the double congruence. Okay, all right. Okay, I'll see you Thursday. Okay, thank you so much. You guys have a good night, okay? Bye, everybody.